This is a model of a Lacrosse helmet, and I just wanted to show this and walk through it with you to show how something like this might be created. This is a little different than some of the other models that we've shown, and it has some interesting techniques in it that can be reused in multiple situations. One of the first things you can see right out of the gate is that, yes, it's symmetrical. This is one of the first things that you got to ask yourself about a new model. Is this model really symmetrical, and is it going to remain so? If yes, then it saves you a lot of work in the end. It causes some extra work just in organization. As with most models, I start out with a bunch of layout material. And I've got some planes, and you can't just revolve a shape and make it into a helmet. It really doesn't work that way. So let's take a look at the first feature, which is boundary surface. And it's made from several sketches. We just use the cross section. Each one of these is constructed with a spline, and they can be tweaked to get the exact profile that you're looking for. Keep in mind also that the curvature comb that you see on some of these is a help to keep the model smooth, and you can also use this for a bit of draft control on a crazy spline. This feature, when it's finally created, so it really doesn't look much like the finished product. We still got to trim the bottom. We've got to trim the hole out of the face area. We got a neck trim. I always recommend overbuilding your surfaces if at all possible. The visor trim does the same thing. If you were to try to make this with the hole in it all in one go, I don't think there's a way that you'd succeed. You'd have to at least make the round part of the helmet first and then the face guard later. But doing it all at once and then trimming it back is a much better way to go. I use this move copy body in this case to get an additional surface that I'm going to trim out. Next, I use a surface offset. This gives me another surface that I can work with, another trim for the front vent. And we're going to add some shape in this area. So now we're going to trim out an area in the back. And this is all done with sketches. We've got a notch in here because we're going to fill this back in with another feature. Now, you remember that I did this move copy body up here. Well, let's see what we've got in our surface bodies folder right now. I've got a copy of the original. So I've got this edge that I need, and that might be why I copied that body. Because I knew that I was going to need that edge, and if I trimmed it away, I wasn't going to have that anymore. And I've still got the offset and the main surface body. To get good at surfacing, you really have to concentrate on your body management skills, and that's going to include using this folder very frequently. Add back in now, we've got this lower back detail. So what happens here was there was a little ridge that I wanted to put into the model. I couldn't get that in the initial boundary surface. So I cut out the shape and I just put it in. The lower back detail, if I edit the feature, uses a curvature to face setting at this edge, curvature to face setting in direction 2, and then a sketch in the back that has this sharp kink in it. And that one just has a normal to profile setting so that when the part is mirrored across, it's symmetrical and smooth across the center plane. I control how that sharp edge fades down into smooth by using an additional sketch here that's a little less severe, a little less sharp in that area, and that has no curvature control. And neither does this bottom edge, which is used from the copied body that we mentioned earlier. And then you can see that this gradually fades down into a smooth surface. You'll be able to see that easier if we turn off the edges. Okay. And you can see that fade come down. Apparently I needed another shape in the back. This new feature that I created, I trimmed that out as well. And I'm going to make another feature which has another scalloped shape that fades down into a smooth face. And that was done exactly the same way as the larger feature. Again, I couldn't have done that all in one feature. We've got a vent area up front. The vent dome, we're making another shape on the inside. So all these surfaces are going to trim out against one another. Now we've got a nice shape where the vent for your mouth is inset slightly from the rest of the helmet surface. Split lines can get you very far in surfacing, and this one in particular uses a technique that was kind of developed about the same time that I created these models. Part of product design and part of what I'm doing here depends very heavily on hiding and showing surface bodies. And a lot of times you can use your display pane here to do that. Or just right clicking on features and using the hide and show. Let me explain what happened with this surface. I created a split line that created that outline on the 3D face of the helmet. And then I used a surface extrude. And what it's extruding from is it was extruding from this face. And you might have seen this if you saw some of the automobile demos. That I use this quite frequently for trim around windows, gaps around doors, lights protruding out from a surface, things like this. So the way it works is, first of all, you create a sketch, and then you project that sketch onto a surface to make a split line, and then you use that surface to create the extrude. And in the from area where you would normally have a sketch, you now have a face. Once you put a face in that box, SolidWorks knows that you know what you're doing, first of all, and that what you want is really a 3D effect. It's not an extruded surface per se, but it is a very cool effect. Okay, so what it does is it pushes that in a certain distance, and you can give it a draft at the same time. So it's extruding from a 3D surface in a given direction, and in here I specified the direction using the right plane, but you could create a reference sketch and use a sketch line as the extrude direction, and it doesn't have to be parallel to any given plane. This cap end option allows you to put the surface. It would essentially be an offset surface on the inside, and so if I add that, then I get that surface. If you had to do this all yourself manually, it would take. You'd start from that split sketch, and you'd extrude a regular surface, and then you'd offset this surface, and then you'd have to trim this against that. Okay, so this extrude surface really saves you a lot of time and effort and confusion in the feature tree. Thanks for watching part 1 of the helmet. Please come back for part 2.